let's not look at Uzbor. Let's say we have AISI 1045 and aluminum. How will you make use of data like this? Anyone? Think about productivity. I'll give you an example. Okay, I'll give you an example. Okay. So between just a case study, okay, between January 2018 to January 2019, okay, your company produced 1,000 parts. Okay. Then between January 2019 to January 2020, okay, your product is very good. Okay. All of a sudden, your order is 10,000 parts now. Okay. So now, if this material is aluminum, what will you do? Anyone? If this material is aluminum, okay, January 2018 to 29 you manufacture, all of a sudden your order is now 10,000 parts. As an engineer, knowing there's aluminum, that C is equal to 0, what do you do? Anyone?
We'll just increase the strain rate.
Increase the speed of what? Deformation. Okay, i.e. reduce production time. Right? You could do it. Why? Because you deform it at different strain rate. It's okay. Right? It's okay. Now, what if now, right? What if now, okay, what if now your material is made of steel? So when the material is made of steel, right, or AISI 1045, I call it AISI for this case. I call it AISI 1045. So you know by looking at the rate of deformation, you increase your speed, what will happen? The stresses go up, right? You can see the stresses, your stresses are going up. Okay, stress increase. So you make 1,000 parts made of steel. You did a very good job. Your company is superb within tolerance. Now you have an order of 10,000 parts, or you have an order of 1,000,000 parts. What will you do?
You outsource them.
Right? So the first thing is what? The first thing is you outsource. Is outsource always a good thing to do?
It's a business decision. You
Yeah.
can't really say.
Yeah, it's a business decision, but you are the one that help the business people make the decision because they have not an idea what C is.
Buy more equipment.
Aluminum is easy to work with, so if it doesn't have to be like very precise, it might be worth it.
No, now we're talking about steel now, okay?
Oh, okay.
Buy more equipment, okay? And this equipment, I've seen this is a capital investment. And buy equipment, this equipment is not that you go to Lowe's or Rona or Home Depot. I want that, you buy and you make. And it might take you 2 years delivery. Yes or no? So at the meantime, what do? So from January 2019 to January 2021, for example, okay, you home manufacture, okay, you outsource, and you need to order the what? Equipment. Okay, you need to order equipment.
Can you
Right.
run longer shifts?
Yeah, but you can run longer shift. You can have 3 shifts. That's where the homemade comes. You can run 3 shifts, but you're not going to make in production. It's all of a sudden you increase by what? 10 times. Okay, maybe all of a sudden you increase to 1 million. All of a sudden, okay, your business is, your quality is good. Your client loves you. 1 million parts you make. Okay, so you're absolutely right. You can increase the number of shifts. Okay, you can outsource, and you can order equipment. Now, listen, this is what this value can help you on, right? Can help you make decisions like this. And always remember, the manufacturing world is a cruel world. I'll tell you why. It's a cruel world. Okay. Every year, okay, so let's say you have an OEM, okay, and you are tier 1. We are working in tier 1 industry. Okay, OEMs are like the Honda, okay, the Toyota, whoever. These are the OEM. The tier 1 are companies like Linamar, Magna, Multimatics. Okay, these are tier 1. They supply to the Honda, to the Toyotas, to the Ford, to the General Motors. Okay. And every time, okay, the cost per part, okay, the cost per part, let's say in 2018, the cost per part is $10. Okay, if they were to maintain, for example, if they were the order is always 1 million parts, they will require 2019. I would like this to reduce to $9.50. Okay, 2020, I would like to reduce this to $9.30. 2021, I'd like to reduce to $9. Now, how do you know this is possible? Always there's a reduction. Yes or no? Regardless of the year. Every year, you want to do business with me, you have to reduce your cost. You have to or not. Okay, I'll look for the next company. So a strategy is to look at your C value. Okay, and your C value, by looking at C value, if it's aluminum, it's no brainer. Yeah, we can reduce the cost, easy. Okay, but if it's something like dual phase steel, okay, how much can you reduce by, and what sort of infrastructure can you invest? So if you make 1 million parts every year, right? You can benefit from the profit. What are you going to do with the money? Are you going to give yourself a big fat paycheck or pay dividend in stocks, or you're going to invest in your equipment? If you don't invest in equipment, okay, equipment that consume less energy, for example, equipment that is easier to maintain, lower cost to maintain, you're going to lose out. Okay, so by looking at the C value, right, you can make corporate decision like this. Not everything is all given to the finance department to make decision. The finance department, at the end of the day, they will make a decision. The decision made is from data given from you guys. Okay, so that is where it's critical to be able to relate what I'll just show you, to relate mechanical properties to costing like this. Okay, are you going to home manufacture? Are you going to outsource or order equipment? Okay, if your C value is very low, right, you look at the cost, you say, okay, we can increase the speed of deformation. Our machine tool is okay. We don't need to buy new machines. Okay, we just need to take care of human beings in labor. There you go. You make decision like that. Okay, so on that note, I will end my lecture. Okay, so those of you who have questions, you can stay behind. Those of you who have no question, I'll see you guys next week. Now, on Monday, I will post the assignment. Okay, you get your first assignment on Monday. Okay, if that's the case, I'll see you guys next week. Take care and be prosperous. Okay.
So I have a question.
Yeah. Yes. Go on. Let me stop recording first.
How does that speed of deformation? Why does